All right, today we are doing section 4.5. It is going to be the converse of the Pythagorean theorem. We are going to use it in order to classify triangles. So for our warm-up, we are going to solve the equation for the missing variable. Assume all variables are positive, and we are going to leave these as simplified radicals. We are not going to be rounding them. You do not have to copy down the directions. You do need to copy down the original problem for each of these, and then we will solve them. All right, number 2 is similar to number 1, except this time we don't have c squared by itself, but we'll start off the same way. What is 4 squared? What is 3 squared? In order to get c squared by itself, what am I going to have to do? Add 16. 9 plus 16.
25.
The square root of 25? So on number 2, c equals 5. On number 3, what is 10 squared?
100.
What is 16 squared? 196. To get c squared by itself, what do I need to do? Add 100. C squared equals 296. To get c by itself, I need to square root both sides. Is 296 a perfect square number? No. So we need to simplify it. What can I break 296 into?
What can you sweat?
You tell me, 12 times what?
12 pounds, 8.
We could go by 2. 2 times what? It is not, so we have to see if we can break it down.
I got it. It's 178 times 2. What bro? Stop doing mom.
So that means the square root of 356 is going to simplify to what? 2 root 89. What is 7 squared? 49. What is 15 squared? We need to get a squared by itself. What are we going to do? Subtract 49. We get that a squared equals 176. In order to get a by itself, square root both sides. Can we simplify the square root of 176? Are we sure?
Yeah, you can, but like...
2 and 88. 88 breaks into
11 and 8.
we can use 11 and 8. 8 breaks into 4 breaks into. Okay, what can come outside of that radical?
4.
How many 2's? 2, which gives us a total of 4. 2 times 2 is 4. Times the square root of 11. On number 5, I need 5 squared.
25.
What is 12 squared? To get b squared by itself, subtract 25, b squared equals 119. Are we going to be able to simplify the square root of 119? Breaks into 17 and 7. Those are both prime numbers. So it cannot simplify any further. On number 6, if we square 5 square root of 4, that means we are squaring 5 and we are squaring the square root of 4. So there are multiple ways you could simplify this. One way would be to take the square root of 4. What is the square root of 4? The square root of 4, not 4 squared. 2. So this becomes 5 times 2 squared. What's 5 times 2? What's 10 squared? What's 8 squared? In order to get b squared by itself, what do I need to do?
Subtract 64.
What do I get?
36.
To get b all by itself, I need to.
Square root.
What's the square root of 36?
6.
So on this one, b equals 6. All right, for our warm-ups, these ones ought to go much quicker. We just took a quiz over most of this yesterday. If we have two sides of a triangle that are congruent, then those base angles also have to be congruent. So on number 1 for the warm-ups, x is going to equal 52. On number 2, we again have two sides that are congruent. That means the angles across from those sides are congruent. So I know the angle down here at the bottom is also 20 degrees, but I am asked to find the third angle. Brandon,
I might be wrong. My understanding is it 140?
how did you come up with that?
Because you said all three angles equals 180, and then if I subtracted 20s, I got 140.
Perfect. All three of them have to add up to 180. So we subtract off the ones we know, we would be able to find the one we're missing. On number 3, we are given a triangle. We have two sides. One of them's 5.2, the other's 3.6. We're looking for the third side. The only other thing we know is that those base angles are congruent. Well, if the base angles are congruent, the sides opposite those angles have to be congruent. That means that that side marked with an L also has to measure how much? 5.2. Number 4 is going to look similar from our radical review from the top. This is a right triangle. That means that we can use the Pythagorean theorem. A squared plus b squared equals c squared. Remember that c is always the longest side. So that means 26 has to be c. They labeled b over here, so 24 is what I will use for a. We plug all of that in. 24 squared plus b squared equals 26 squared. 24 squared is 576. 26 squared 676. To get b squared by itself, I have to first subtract. So I get b squared equals 100. If I square root both sides, I get that b equals 10. Number 5 is similar. It's a right triangle. We're going to use the Pythagorean theorem. The longest side is 34, so that's what I'll use as C. A is what we're missing, so we will use 16 for B. So we are going to have A squared plus 16 squared equals 34 squared. What is 16 squared?
256.
What is 34 squared?
1156.
A little louder.
1156.
Thank you. When we subtract 256 from 1156, we get A squared equals 900. We take the square root. What do we get for A? 30. Number 6, again, is a right triangle Pythagorean theorem problem. This time we're missing C, the longest side, so the other two just get marked A and B. It doesn't really matter which is which. So we have 14 squared plus 16 squared equals C squared. What is 14 squared?
196.
196 plus, we just did that one, is 256. If we add them together, what do we get? 452. We have to square root them. Is 452 a perfect square number? No, so we break it up. We can divide 452 by what? What do we get? 4 and 113. All right, I don't think 113 is going to break down. Can anybody get it too? But 4 is a perfect square number. 4 can break into 2 and 2. So this would mean that C is equal to 2 square roots of 113. All right, our last two problems are distance problems. Remember, the distance between 2 points is found by taking x2 minus x1 squared plus y2 minus y1 squared. So on number 7, what are my x's? 1 and negative 2. So it doesn't matter to me which one you want to plug in where. I'm going to take negative 2 minus 1 squared plus, on the other one then, I would have to take 5 minus 1 squared. Negative 2 minus 1 is a negative 3. A negative 3 squared comes out to be a positive 9. What is 5 minus 1? Square it. If I add 9 and 16 together, I get 25. What is the square root of 25? 5. So the distance between those 2 points would be 5 units. On number 8, we're using the same formula. We have the square root of. On this one, my x's are negative 2 and 5. My y's are 3 and negative 1. Negative 2 minus 5 is negative 7. What's negative 7 squared? 49. Plus 3 minus negative 1 is 4. What's 4 squared? If I add 49 and 16, what do I get? 65. Is that one going to simplify? No, it breaks down into 5 and 13. Both of those are prime. So we are going to leave it as the square root of 65. We have the converse of the Pythagorean theorem. In words, if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So this is just going backwards from the Pythagorean theorem. Before we said if the sum of the squares of the two sides was equal to the third side squared, then we knew it was a right triangle. Now we're saying if it works, then we know it's a right triangle. All right, so on these we have to decide if we get a right triangle or not. We are still going to be using that same formula, a squared plus b squared equals c squared. But we, this time, are going to be deciding if they're actually equal. If it comes out that the two sides end up being equal, then it's a right triangle. If not, it is not a right triangle. Who can raise their hand and tell me which number do you think we need to plug in for C on example A? Julian? 13. I've said that C has to be the longest side. So for us to try this, we have to use the longest side as C. The other two, it doesn't really matter as much which one you mark A, which one you mark B. They are interchangeable. So we start plugging it in. We've got 12 squared plus 5 squared. We are trying to see, does that equal 13 squared? What is 12 squared? 5 squared. We are wondering, does that equal whatever 13 squared is? What's 13 squared? Yes, if we add 144 plus 25, we get 169. So those two sides do equal each other. So for this one, we would say, yes, this is a right triangle. On letter B, what do we think C has to be? 10. It's got to be the longest side. The other two, it doesn't matter as much. So I have 8 squared plus 9 squared. We're wondering if that will come out to equal 10 squared. What is 8 squared? 9 squared. If we add those together, what will we get? 145. What's 10 squared? Do those equal each other? Is this a right triangle? No. If they don't end up equaling each other, it is not a right triangle. My recommendation would be to go through and label your sides first. So on this one, C is equal to 37. That's our longest side. The other two, again, with A and B, it doesn't matter as much. So I plug everything in. 35 squared plus 12 squared. I need to know if that equals 37 squared. What is 35 squared? 1,275. 12 squared is 144. What is 37 squared? 1225. Okay. If we add those together on the left, what will we get? So is this a right triangle? Yes. On number 2 on this slide, what has to be C? 20. A and B are the same on this problem. 17 squared plus 17 squared. Does that equal 20 squared? What's 17 squared? 289 plus 289. What's 20 squared? 400. If we add 289 and 289, will that be 400? No. On a problem like this, if you get to this part, you don't have to add those two together. If you have enough number sense to understand that 289 and 289 is not going to be 400, you can just put no. If you're not sure, you can go ahead and add those together. So you better be awfully sure of yourself if you stop at this point. All right, on number 3, what does C have to be? 30, the longest side. A and B can be the other two sides. 24 squared plus 18 squared equals 30 squared. What is 24 squared? 576. 18 squared. And 30 squared. If I add 576 and 324, what do I get? 900. Is this a right triangle? It is. Now, from the sounds of it, about 2 people, I can tell, understand what's going on and what we're doing. How do the rest of us feel about it?
I'm too smart for this.
I will rewrite some of this a little bit bigger and highlight what's important. If c squared is less than a squared plus b squared. So we plug everything in, a, b, and c, just like we've been doing. We see that they are not equal to each other, so we know it's not a right triangle. But c squared comes out to be smaller, the smaller side. Then the triangle is acute. We've already talked about if they do come out to be equal on both sides, that's when we know it's a right triangle. If we plug in a, b, and c, square them all, add a and b squared together, and c squared comes out to be greater than or bigger than a squared plus b squared, that is when our triangle is obtuse. All right, so example A on this slide is telling us to show that the triangle is an acute triangle. So it's saying this definitely is an acute triangle, we just have to show that. So based on that previous slide, that means we need to show that c squared is smaller than the sum of a squared and b squared. Still, when we pick out our a, b, and c, c has to be the longest side. So c in this case will be 7, a and b will be 5 and 6. So when I plug these in, the formulas on the slide before showed c squared being on the left. So if you want to move c squared over to the other side, we can, like they did it. So we are going to compare c squared to a squared plus b squared. What is 7 squared? 49. What is 5 squared? And 6 squared. Okay, so this side stays 49. 25 plus 36 is 61. So I have to decide what symbol goes here. Is it less than, equal to, or greater than? This would be a less than. And if c squared is less than the sum of a squared and b squared, that is how we know it's acute. So notice I did not put a symbol in it until the very end when I compared them. So this shows or proves that that triangle is acute. The next one, I am trying to show that it is obtuse. So I'm going to want my c squared to be greater than if I'm going to be successful here. C has to be the longest side, so that would be 18. A and B are going to be 3 and 16. So on one side I've got the 18 squared, C squared. The other side is going to be A squared plus B squared. What is 18 squared? 324. 3 squared. And 16 squared is 256. If I take 9 plus 256, what do I get? 265. How do these compare? 324 is greater than 265. And if C squared is greater than the sum of A squared plus B squared, we know it's obtuse. All right, we're going to go through these pretty quick because we just did some just like them. On this one, C has to be 20, the longest side. And then we have our A and B. So C squared is 20, so I put 20 squared on one side. The other side I'm going to have 14 squared plus 18 squared. 20 squared is 400. 14 squared is 196. 18 squared is 324. If I take 196 plus 324, what do I get? 520. How does 400 compare to 520? It is less than, which proves or shows that that triangle is acute. Again, my longest side is always C. The others are A and B. 29 squared, we're comparing that to 11 squared plus 20 squared. What is 29 squared? 841. 11 squared is 121. 20 squared is 400. If I add 121 and 400, I should get 521. How does 841 compare to 521? It's greater than. If C squared is greater, that means it's obtuse. All right, these ones, we don't have a triangle shown. We just have these numbers, and we have to decide acute, right, or obtuse. I would recommend setting them up the same way we did the last four. C is always going, C is always going to be the biggest one. So you can go through and label them right away. I would still put C squared on the left, or do C squared first. So 15 squared compared to 9 squared plus 12 squared. 15 squared is 225. 9 squared is 81. 12 squared is 144. If I take 81 plus 144, what do I get? 225. So how do these numbers compare? They're equal to each other, which means that this is what kind of triangle? It is a right triangle. On the next one, we have 24 squared compared to 13 squared plus 19 squared. 24 squared is 576. 13 squared is 169. 19 squared, 361. If I take 169 plus 361, what do I get? 530. How do these numbers compare? 576 is greater than, so what kind of triangle is it? obtuse. On the last one, 28 squared is getting compared to 20 squared plus 26 squared. What is 28 squared?
784.
784. 20 squared is
400.
400. 26 squared,
676.
676. If we add 676 and 400, what do we get? 1076. How do those numbers compare? 784 is less than, so it is acute.